The world's great mysteries. Just how were the pyramids built so deep in the Egyptian desert?
A modern $3 billion megaproject is designed to stand for millennia. It requires moving 60,000 tons of raw tectonic mass across international borders. To the public, replicating an ancient wonder with 21st century machines seems like a routine administrative exercise. But inside the complex physics of hyper-heavy construction, the modern world faces a humiliating structural check. It is a calculated engineering calculation where modern logistics completely run out of traction. A massive experiment where digital technology breaks against primitive raw geometry. How does an empire of absolute technological supremacy fail to recreate a monument built 4,500 years ago? Apple Park, the Burj Khalifa, and the world's tallest skyscrapers rest under a complete illusion of supreme structural scale. Yet the entire mass of the Burj Khalifa sits at just 500,000 tons. This metric is a tiny 8% fraction of a single ancient Egyptian monument. The Great Pyramid of Khufu demands the confinement of over 6 million tons of pure limestone and heavy granite blocks. To assemble this colossal formation today, standard geography is completely unusable. Replicating the pyramid structure on unstable, sandy topsoil creates a terminal pressure point, morphing the multi-billion-dollar zone into a massive foundation graveyard. The extreme gravitational pressure forces the bedrock to cave inward, swallowing the structure entirely. Historical logs unseal a critical structural shift, where ancient engineers miscalculated the bedrock density of the bent pyramid, causing the entire asset to tilt violently during development. Today, securing stable tectonic plate acreage and clearing permit structures requires an initial allocation of $120 million before a single block is placed. Once the territory is locked, the modern supply chain encounters an insurmountable operational bottleneck. The construction plan dictates the processing of 2.3 million independent stone blocks, each matching the physical volume of a heavy commercial vehicle. Modern industrial factories operating high-end machinery max out at cutting just 100 heavy blocks a day. This severe performance gap means a single commercial vendor requires 63 consecutive years just to fulfill the initial core allocation. To force this schedule into a tight 5-year production window, an enterprise must construct a massive, multi-million-dollar cutting network running 250 custom diamond wire industrial saws simultaneously inside raw stone quarries. This massive infrastructure array demands a constant, uninterrupted 20 megawatt power supply. The aggregate energy consumption required over a 5-year timeline matches the entire grid usage of a developed nation for an entire day, inflating baseline utility expenditures past $155 million without accounting for transit taxes. The ultimate breakdown of modern tech occurs at the final assembly phase. Heavy logistics requires moving 2,400 trailers across a rigid 900-kilometer transit corridor over 5 years, maintaining a continuous 10-minute arrival pattern at the grid. Once the assets arrive, the construction script hits an absolute physical wall. The upper structural layers demand lifting 80-ton granite sections up to a terminal height of 147 meters. No commercial tower crane on Earth possesses a mechanical arm capable of manipulating 80 tons at that horizontal radius. Physics dictates that as a crane arm extends, its lifting capacity drops exponentially towards zero. To bypass this barrier, engineers must deploy a complex, risky network of specialized mega-tower cranes, constantly assembling and dismantling the machinery to creep upward with the stone. Replicating the absolute precision of the original design, where blocks are fitted within a 1 millimeter margin of error, requires outlays exceeding $3 billion. In a hyper-materialistic world economy, spending billions to erect an object with zero commercial output or data tracking value is a financial impossibility. We live under an absolute assumption that modern human advancement can easily outbuild the primitive past. We believe our digital supremacy makes us masters of the physical world. But the ancient architecture hidden beneath the desert sand exposes our profound logistical limitations. Our modern global economy can easily build transient glass offices, but it is completely bankrupt when challenged by absolute structural permanence. Think about the volatile infrastructure you inhabit every single day. Your modern world trades real, enduring stability for immediate financial metrics. If an entire globalized network of machines and billions in capital can barely match a 4,000-year-old layout, who really possesses the ultimate technology?